Alright, so that brings us to combined gas law. Combined gas law just combines all the components of our previous three gas laws. So you're going to have all of them in there. You're going to be able to see Boyle's law, pressure times volume. You're going to be able to see Charles' law, volume divided by temperature. You're going to be able to see Gay-Lussac's law, pressure divided by temperature. So it's actually just all three variables combined, because there really aren't many real world conditions where you can hold one of those things constant, right? So all three things are changing in these applications and these new questions. So you can't hold any of them constant, you can't get rid of them. Now, that being said, from here on out, you can actually use this equation exclusively, because as soon as you know that temperature 1 and temperature 2 are the same, excuse me, I'm trying to put a 1 there. As soon as you know that they're the same, you just cancel them out, and then you know that you're just doing Boyle's law. It's just pressure times volume equals pressure times volume. So in the future, when I don't actually tell you which law to do, you just set it up like it's a combined gas law, and you go ahead and cancel out whatever stays the same, and then you're doing one of the other three laws. You don't even need to know which one it is. So as long as you start out with this equation, you can do any of the problems we've done already. So that's the way I usually think about it. That's why I tell you guys to go ahead and collect what you know. Like right away, I know a pressure, it's 0.2 atmospheres. I know a volume is 80.0 milliliters. I know a temperature, it's 27 degrees Celsius. So 273 onto that is 300. Gotta be careful, that 300 would have three sig figs. And then it says, what volume will the sample, what volume will the same gas occupy at standard conditions? Now, again, standard conditions tell me something. STP means I have a temperature that I can use. I have a pressure that I can use. The thing that I didn't know is the volume. So PVT, I'm looking up those standard conditions for a couple of these things. Temperature is 0, right, which is actually 273 Kelvin. Right, so you don't really use 0 ever, but it's a good thing to remember. Pressure standard is 1 atmosphere to match this other atmosphere. I could have used 760 torr if the other thing was torr, but 1 atmosphere with at least 2 sig figs, because the first one had 2 sig figs. I'm solving for volume. Right, this is just a bigger algebra problem. So I'm going to try and fill in the blanks. I got a 0.2 times 80 divided by 300 equals 1 times x divided by 273. Now this one is a little bit more complicated. It's not quite a fish method, so you do technically have to do some algebra here if that's something that you usually do, fish method. So I would just cross multiply to make this work, right? You can do your 0.20 times 80 times 273 equals 300 times 1 is just 300, so 300 x. Then you'd actually divide that 300 back over, so you can leave it there initially too if you understand how that works. But you need to get x by itself, and you need x to be on the top. So you should probably start out with a cross multiplication if you don't know how that works, right? Because this isn't going to be a simple fish method. On some previous examples, I solved for x on the bottom, but that's because I used that idea in my head, right? But I'm solving for x here, so I have to do that math. 0.20 times 80 times 273 divided by 300. And it'll give me an answer. In this case, x equals 14.56. And I can only have 2 sig figs in my answer, so I'm going to round that to a 15. And since I was looking for a volume, and my initial volume was milliliters, this is also milliliters. So 15 milliliters would be my answer. Right, this is one that you got to be careful on. You can try and predict what it is ahead of time. The pressure did get bigger, so that would make you think the volume gets smaller, Ed. So that seems reasonable. The temperature got smaller though, and that also would make you think the volume got smaller. So this is easy enough to say yes, that's a reasonable answer. 15 is smaller than 80, but sometimes the conditions change and one's getting bigger, the other one's getting smaller. Sometimes it works out so that one of those factors makes you think your answer would get bigger, but the other one says it gets smaller. And sometimes that happens and they cancel out and it stays the same. It doesn't even change, right? So you have to, it's a little bit more complicated to guess what's going to happen, but either way, if you do your algebra correctly, you're going to get the right answer. So just work it out, find an answer, compare with your neighbor, if anything else. All right, so that's all the combined gas laws for now. It's the combined gas law, but that's all of the gas laws to this point. All right. So